So question number 1 is asking us when a graph is concave up. And we know concavity comes from the sine of the second derivative. So I'm going to find the second derivative, which I like. It's nice and straightforward. Whoops, I guess I got to find the first derivative. I got too excited there. So my first derivative is 3x squared minus 12x, and my second derivative is 6x minus 12. So I'm going to take that second derivative, I'm going to set it equal to 0, and I see I have something important going on at x equals 2. I should also be asking, like, where does the second derivative not exist? Well, it's a polynomial, no asymptotes, no holes, no problems. So I'm going to plug numbers in on either side of 2 into the second derivative. If I plug in a 0, I get a positive times a negative. And if I plug in like a 3, I get a positive times a positive. And so my graph is concave up from 2 to infinity, or when x is greater than 2. All right. Question 2, another cubic function. They're asking for the maximum value, which means they want the y-coordinate on a closed interval, which means check the endpoints, right? So I like to just organize myself with just a little bit of a t-chart here. So I want to check 0 and 6. And then we also need to see candidates for maxes and mins. Maxes and mins come from the first derivative. So we've got 3x squared minus 12x minus 15. I'm going to factor out the 3 and set it equal to 0. And so I have something interesting happening at 5 and negative 1. Negative 1 is not in my interval, so there's my 5. Actually, I could also check, by the way, to even see if 5, what kind of critical point 5 is. To be honest, I think that would be a smart choice. Just because if it's a minimum, then I don't even need to put it on my sign chart. So again, you can go ahead and look at the negative 1 and the 5. Maybe I'm doing too much work here. But if I plug in a 0 into my first derivative, that's positive. Negative, positive, that's a negative. If I plug in a negative 2, positive, negative, negative. If I plug in like a 6, positive, positive, positive. So that means I have a maximum at negative 1 and a minimum at 5. So I kind of like that I did that, because now I know, well, the answer is not going to be a 5. But be very careful. Look at how that number is here. And it'd be easy to fall into their trap. But they're asking for a maximum, and we have a minimum at 5. Also, they didn't even want the x-coordinate, but it's easy to fall in the trap. All right, I want to find the y values here. If I plug in a 0, I get a 0. Now, this is a non-calculator question. Don't overthink it. They want me to plug in a 6 to the original. Factor if you want. I think that's going to make that nicer. So I have a 6 out front. 36 minus 36 minus 15. Either way, this is going to be a negative number, which is telling me that, oh, the biggest y value will be 0. All right, so on question number 3, they are telling me that my function has a positive first derivative, meaning my graph is increasing, and a negative second derivative, meaning we are concave down. I'll come back to that, but which of the following could be a table of values for my function f? Well, first of all, if my graph is increasing, it can't be C or D or E, because this graph is decreasing, right? So that's great. So then what do we do from there? If the graph is concave down, remember that means the first derivative is decreasing, or the slopes are decreasing. So let's take a look at the slopes. I'm going up 2 and over 1. I'm going up 3 and over 1. I'm going up 4 and over 1. Well, those slopes are increasing. This is concave up. Whew. So I really hope that what I'm about to see shows me what I want. So I'm going up 4 over 1, up 3 over 1, and up 2 over 1. And so, again, using slopes to help us talk about concavity, we've now seen that a couple of times in the last week or so. All right, so question 4 kind of combines questions 1 and 2 in a sense. They're asking me to take this, gosh, it's another cubic, and they want to know when this graph is both concave up and increasing. So concavity comes from the second derivative, increasing comes from the first. So let's go ahead and talk about some derivatives here. So f prime is 12x minus 6x squared. And f double prime is 12 minus 12x. So I'm really going to do the same steps for both of these, right? So I am going to use, I'm going to factor this and set it equal to 0. Let's take out a 6x. So my critical points are 0 and 2. So this is my sign chart for f prime. If I plug in a 1, I'm starting in the middle for some reason, I have a positive times a positive. If I plug in a negative 1, I have a negative times a positive. And if I plug in a 3, I get a positive times a negative. Okay. So for sure, if they're asking about when the graph is increasing, it's definitely not going to be any negative numbers, and it's not going to be anything after 2. So I think I could probably rule out D, but we'll come back to that. All right. Let's do the same thing with the second derivative. So I'm going to factor out that 12, which gives me only one place that I need, one number to put on my sign chart, which is 1. So I'm going to pick a 0, and when I plug in a 0, I get a positive. When I plug in a 2, I get a negative. So let's stack these sign charts. I'm going to stack them up over here. Actually, I'll just stack this orange one down here. So here's my 1, and it's positive, 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 negative, negative. So I just did a lot of signs. I want to know when my graph is concave up and increasing. So I'm looking for positives on both. And really, that just happens from 0 to 1. Good. All right, let's grab a calculator. Mine's sitting right here. We're going to make sure that calculator's in radians, which it is. So, question 5, they are giving us the first derivative, and they would like to know when the original has a relative maximum. So we're going to look to see when the first derivative changes from positive to negative. All right, so I'm going to go graph my first derivative. So let's clear all of this out. Oops, I just covered it up. I have the sine of x squared minus 3, and I'm going to be smart, and I'm going to go change my window to go from negative 3 to 3. Oh geez, now I've done it. Oops. Okay, I wasn't really worried about the y values of my range, just because I was just looking for when it crosses the x-axis. So I'm looking to see where I cross from positive to negative. So it looks like here and here. So let's go find those. 1, 2. So how about between negative 2 and negative 1? So I have a negative 1.732. I'm going to just take a peek. So, well, I can rule out that one and that one. Actually, I think I can rule out all of them now. Like, just save yourself some time just by using that process of elimination. I mean, granted, if I have more time, I should go double check to make sure. But look, yeah, that other one looks like it's at 2.4. Perfect. So, by kind of just looking at my options, I really saved myself some time. Gosh, we're getting the answer of A quite a bit in here, aren't we? All right, let's take a look at the back. Question number 6. So we have a table for f prime, and they just want to know what could be going on. All right, well, don't let the decimals really mess with your head a whole lot. It looks like, well, that's even a horrible graph. My x values are kind of centered around 1. And my f prime values are kind of hanging out here around 1. So it looks like we kind of go 0.98, 0.99, 1, 0.99, 0.98. This very much not to scale. This is a representation of the data I see in the chart. Great. So they want to know really about f increasing or decreasing. Concave up, concave down. All right, well, let's take a look. If this is my first derivative is always positive. So I'm thinking, well, f is not decreasing, or my first derivative would have been negative. Okay. Let's talk about concavity. We said on the front, concavity comes from if the slopes are increasing or decreasing. Well, my slopes are increasing and then decreasing. So I think we're concave up and then concave down. So I think really the only thing we can say is that my original changes concavity. It has a point of inflection. Doesn't say where, just it's going to have one because my first derivative increased, then decreased. So that's letter C. All right, let's take a look at 7. So we have another table. The graph is continuous. Which of the following statements must be true? Again, I don't think it's the worst thing in the world to kind of sketch these points. Nothing crazy. -5, -9, 0, 1, and 2, 5. Okay, so this is F. Does F have at most 1, 0, one x-intercept? Well, it could have hundreds of them, right? My graph could go doop, 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 right? It could cross the x-axis a lot. So I think it has at least 1, 0. Does my graph, this graph, have a relative max at x equals 2? Does this have to be the highest point? No. I think my graph could go woo and then come back. Is there a place between these 2 points that the y value has to be 4? Well, let's take a look. If this is 5 and this is -9, to get from -9 to +5, the intermediate value theorem says, yes, if your function is continuous, you have to pass through every y value in between. So I think it's C, but I'm going to just read D instead, in case. Is there a place between these 2 points where the slope has to be 2? Well, I mean, we are going up 14 and over 7, so yes, the slope between these 2 points is 2. However, the mean value theorem only works when your function is differentiable, and they did not tell us that, so let's write that down. Only if f of x is differentiable, and they did not tell us that. So that's why it doesn't have to be true, and that's why our answer is, again, C. All right, last question. So this is a giant graph. This is the graph of the first derivative. Which best describes the graph on this interval? So it looks like they're talking about maxes, mins, points of inflection. All right. Well, we kind of already reviewed from positive to negative or vice versa. So I'm going to have a maximum here because my first derivative changes from positive to negative. Nothing here. I'm going to have a minimum here because I changed from negative to positive. So 1 max, 1 min, 1 min. Okay, so I'm going to cross off C, D, and E. All right. So it really comes down to points of inflection. And kind of relates back to question 6. Points of inflection are when the first derivative changes from increasing to decreasing, which means the first derivative has a turning point or a max or a min. So let's see, it turns around here, here, and here. So I think we're going to have 3 points of inflection.